questions 21 through 25 on the 2011 grade 12 AMC 12B. The arithmetic mean of two distinct positive integers x and y is a two-digit integer. The geometric mean of x and y is obtained by reversing the digits of the arithmetic mean. What is the absolute value of x minus y? So the arithmetic mean of these two integers, of course, is x plus y over 2. And they're saying that it's some two-digit number where the first digit is, say, a, and the second digit is b. And if we write it out, it would be 10a plus b, right? And then they're saying that the geometric mean, which is xy square root, is the reversal of this. So instead of ab, it's actually ba. And if you write that out as an actual number, it's 10b plus a. And we can simplify this a little bit. X plus y can be called, if you multiply through by 2, 20a plus 2b. And if you take the square root of, or the square I should say, of both sides, it would be 10b plus a all squared like that. So now what we have to do is some fancy algebra. And some of this, of course, you already know, but it's worth refreshing. If you have, for example, x minus y times x plus y, and you expand that, that becomes x squared plus y squared. If you have x minus y times x minus y, if you expand that, it becomes x squared minus 2xy plus y squared. And if you have x plus y times x plus y, then expanding that, you get x squared plus 2xy plus y squared. So of these, the one I need is the one that has x minus y in it. So I want this one right here. So I want x minus y times x minus y. And that would be equal to x squared plus 2xy plus y squared minus 4xy. If you do that, you will get this, which is this. So that's just a little bit of algebraic manipulation. This side, of course, just becomes x minus y squared. And then this side, those terms are just x plus y times x plus y. And then we've got this minus 4 times x, y. And this we know, and this we know in terms of our a and b. So x plus y times x plus y is this times itself. So it's 20a plus 2b all squared. And then xy is this right here. So we put that in 10b plus a all squared. And this is, of course, x minus y squared. Now we have to expand this. So this will become 400a squared plus 80ab plus 4b squared. And then if you expand the second term, you'll get minus 4 100b squared plus 20ab plus a squared. And then let's see how many like terms we can collect. 400a squared plus 80ab plus 4b squared, and then minus 400b squared minus 80ab minus 4a squared. Collecting like terms, this becomes 396a squared minus 396b squared, because these two terms cancel. And then factoring, we get 396a squared minus b squared. And 396 is 36 times 11. And this is going to just be a minus b, a plus b. And 36 I will write that as 6 squared. So at this point, we have to start discussing this. This side, of course, is a perfect square, x minus y squared. That means this side must also be a perfect square. Now, the 6 is a perfect square, so that is the only one that is matching so far. But the rest of these, we have to fit them in a way that they become perfect squares. Now, a and b are individual digits. So a plus b could be 11. If it is, it will pair with this 11 to create a perfect square. But a minus b, that is what we have to now figure out. A minus b all by itself, it must be a perfect square in order for everything to be a perfect square to match that side. So what are the possible values of a minus b? Well, they are single digits, a and b, so the only thing we could get is either 1, 4, or 9. We can't get a 16 by subtracting 2 single digits. So let's work with each of these. Let's first start with a minus b is 1, and then a plus b we had already set as 11 up here to match with that 11. If we add these, you get 2a is 12 and a is 6. If a is 6, that means b is 5 if you substitute it back into any of these. Well, that's a pretty good pair. What about if we have 4 for a minus b? If you have a minus b equal to 4 and a plus b equal to 11, this is not going to give me an integer solution. It will be 2a is equal to 15 when a is going to be equal to 7.5. And similarly, if you do a minus b is equal to 9, that will also not give me an integer solution. It will be 9, a plus b is 11 as before, and that would be 2a is equal to 20. Now a is going to be 10. That is an integer, but the problem is that a has to be a single digit. So these are the solutions that do not work. So the only one that works is a equal to 6 and b equal to 5. So if that is the case, that means a minus b is 1. So x minus y squared is 6 squared times 11 times 1 times 11. So it's really just 6 squared times 11 squared. And therefore, if you take the square of both sides, square root, I should say, that means x minus y will be 6 times 11, which is 66. And that is what they're looking for. So x minus y is 66, and therefore number 21, the answer is D. Let T1 be a triangle with sides 2011, 2012, and 2013 for n greater than or equal to 1. If T at n is equal to ABC triangle, with D, E, and F are points of tangency of the incircle of triangle ABC to the sides AB, BC, and AC respectively, then T and n plus 1 is a triangle with side lengths AD, BE, and CF if it exists. What is the perimeter of the last triangle in the sequence Tn? So let's first create some triangle and talk about this. So here is our diagram. We've got this triangle, and we can label it, of course, A, B, C, and then we will label the points of tangency, D, E, and F. D is here approximately, E is here, and F is here. And then, because of this triangle being tangent, we can draw lines from the center to the vertices like this. And what that allows us to do is figure out that some of these distances will be equal. So for example, if I label A to F as X, and A to D will also be X, because those are similar triangles. And very similarly, if I label B to D as Y, then B to E will also be Y. And if I label F to C as Z, then E to C will also be Z. So we got a few equations here. The first is x plus y in my first triangle is 2011. And then x plus z in my first triangle is 2012. And y plus z is 2013. Now we want a general formula for what will x, y, and z be for each t to the n. What will it be for, well, t1 we know, but what will it be for, say, t to the n? And then we can calculate it for t2, t3, t4, and then eventually we'll get to a t that doesn't exist in the sense that you can't make a triangle. Because in any triangle, remember, we have a fundamental triangle inequality that two sides have to be greater than the third side. Okay? So, let's first figure out this, solve for x, y, and z. But I want a general formula. I don't want numbers. I mean, I do want numbers, but I want a general formula that will help me get numbers for all of these. So to do that, I will let just something equal 2012. So I'll let, say, p equal 2012. If that's the case, this becomes x plus y is equal to p minus 1, x plus z is equal to p, and y plus z is equal to p plus 1. And then now I can solve. So solving these, let's see, the first one I can do, I can subtract. I can subtract this equation from that equation. And if I do, I get y minus x is equal to 1. And then now I can take that equation and add it to that equation. And that gives me 2y is equal to p. And therefore y is equal to p over 2. So that's my first general rule. Then I can continue like this. For example, just substitute that into there, and that should be sufficient to give you x. X is basically going to be p over 2 minus 1, and that's it. So that's my general formula for x. And then z, I can get again by substituting into here, let's say. So that will give me p over 2 plus z equals p plus 1. So that means z is equal to p over 2 plus 1. And now I can start making my list of t's. So using these three general formulas, 1, 2, and 3. So the first one, t1, I have xyz as p over 2 minus 1, p over 2, and p over 2 plus 1. And remember, p, we had made the substitution as being equal to 2012. And when you do plug that in, you get values as follows. This is, t2. And that will give you values of 1005, 1006, and 1007. So now we turn our attention to T3. This time, we're not using P equals 2012, we're using this middle number, 1006. If you do that, you get 502, 503, and 504. And you continue like this, and you get all these values for T4, T5, all the way up to T10. And then when you get to T11, and you use these standard formulas with the right substitutions, you will get the following. 247 over 256, 503 over 256, and 759 over 256. And this is not possible because the triangle inequality does not stand up. This would have to be greater than those two, would have to add up to be greater than the third, and in this case it's less than. So this is the last triangle that actually works with the triangle inequality. So now all we have to do is find the perimeter of that, and the perimeter of that, of course, you just add up the three sides. So 375 over 128 plus 503 over 128 plus 631 over 128. And then when you add those, you get 1509 over 128. 1509 over 128 is choice D. A bug travels in the coordinate plane moving along the lines that are parallel to the x-axis or y-axis. Let A be -3, 2 and B be 3, -2. Consider all possible paths of the bug from A to B of length at most 20. How many points with integer coordinates lie on at least one of these paths? This is the initial path that can be taken. And in particular, let's look at this box here. There's going to be a lot of dots, but let's just look at those ones. Let's count them. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. So 7 times 5, 35. Those will definitely be included in our counting. So we have 35 in the middle. That definitely will be part. And all of these answer choices are greater than 35, so that means we have to add more. So let's add more. And here we go. Now we've added more. We have the original 35 still intact right here. But now on the left and right, we add more because our path can be at most 20. See, in the original, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even if you take the longest route possible, you only get to 10 as a distance. But we can go as high as 20. So that means we can add more points. So that's why I added another 5 going that way and 5 going that way, because that additional 10 added to the original 10 makes a path of 20. So for example, if I go from here to here, it's 1, 2, 3, 4, 5, 6. And then I go another 5. 1, 2, 3, 4, 5. I'm up to 11. Go down another 5. 1, 2, 3, 4. Actually, it's 4. So that we're up to 15. And then 16, 17, 18, 19, 20. So that would be completely allowed according to the rules. Now, originally, I had these guys, which was 35. And then now I added how many more? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I added another 25 on that side. And here, it's the same thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I added another 25 on that side. But as I'm sure you guessed, I can add more on the top and on the bottom. So let's add those. Now we start talking about going north and going south. So let's recap here. Originally we had these that were 35 as here. Then we added another 25 on this side and another 25 on this side. But now I can add more. I can go south like this. And that's possible because my length can be at most 20. So for example, 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So those extreme paths are possible. So how many more did I add? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So 7 times 5, another 35. And it should be exactly the same up here. These dots will basically be like that. So it's the same thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So another 35 there. Now let's see if we are at the answer choices. 35 times 3, which is 105, plus 2 times 25, 50. And that's going to be 155. But 155 is not one of the answer choices. So that means I've got to add more. Okay? Let's think about how to add more. Probably in these areas, I could add a few more. And here we go. So this is the full spectrum of the dots. So we've got our original 35 in the middle there. Then we had an additional 25 that we added here on that side and on this side. And then we added 35 to the north, those guys up there. We added 35 to the south down here. Now let's look at the corners. As you can see, these are an additional 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 here, 10 here, and 10 here. Now those are allowed because that can be done since our path is going up to 20. So for example, let's say we start at A, right? For example, we start at A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You see how I'm able to count all of those? And similarly, you can do that, and you'll notice that every one of these can be included in at least one path, which is what they're asking for. So if you go through this, this is basically going to be all the points. So let's add these up. We have 35 times 3, so that's 105. Then we got those two 50s, 50, and we got the 4 10s, so 40. And this is 195. So the answer to number 23 is C. Let p at z be equal to z to the power of 8 plus 4 root 3 plus 6 z to the power of 4 minus 4 root 3 plus 7. What is the minimum perimeter among all the 8-sided polygons in the complex plane whose vertices are precisely the zeros of P? Well, our first goal is to find out what those zeros are. And then once we have those roots, basically, zeros, roots, same thing, then we can try to figure out what this polygon looks like and calculate its perimeter. So here is the equation. Let's make some helpful substitutions. Let z to the 4th equal x, and let 4 root 3 plus 6 equal a. And I hope this will make it a little bit more simple to factor. And this will be a plus 1. We can now factor this as follows: x, and then minus 1, and then plus a plus 1, like that. So, and then we can substitute back our values: z to the power of 4 minus 1, and then z to the power of 4 plus a plus 1, like that. Well, from this one, we can say that z to the power of 4 is equal to 1. And therefore, since we're talking about complex numbers, z is going to be either 1, either negative 1, I, or negative I. Those are my 4 possible values for z. This one is a little bit more challenging because we have z to the power of 4 plus a, and that's 4 root 3 plus 6 plus 1, so plus 7. That's what that is, and that has to be 0. So that means z to the power of 4 is negative 4 root 3 plus 7. Now that is not as simple as the other one, but there's a few manipulations that can be used to help us. So notice the following. If you have 4 root 3 plus 7, that is the same as root 3 plus 2 all squared. You can expand that and see that is indeed true. And then if you have 2 root 3 plus 2, this is the same obviously as 2 root 3 plus 4, and 2 root 3 plus 4 is the same as root 3 plus 1 all squared. You can expand that and see that is indeed true. So that means root 3 plus 2 is the same as root 3 plus 1 squared, all divided by 2. And therefore 4 root 3 plus 7 is equivalent, if we look up here, instead of root 3 plus 2, I'm going to put in this root 3 plus 1 squared over 2, and that's all squared. right? Just making some substitutions. And this 4 root 3 plus 7, it would be equivalent to root 3 plus 1 over root 2, all to the power of 4. So now we can use that and look at the z to the power of 4 is equal to 4 root 3 plus 7, like that. And make this substitution. Now we've got minus root 3 plus 1 over root 2 to the power of 4. And to avoid making things difficult to understand, what we can say is let some variable w equal root 3 plus 1 over 2. And then therefore z will be w times 1 plus I, or w times negative 1 plus I. And then the third root will be w times minus 1 minus I. And our last one, of course, will be negative I plus 1. And there we go. We just got our 8 roots, 4 here and 4 here. And now I want to put it on a graph to illustrate what this looks like. And here we are. The roots 1, negative 1, I, and negative I, those are here. Here's 1, negative 1, I, and negative I. And then the other ones, which are these ones down here, are plotted as well. We've got some w, which we have a value for, but it's easier to just put it as w. 1 plus I, then of course 1 minus I, negative 1 minus I, and negative 1 plus I. So this is the polygon. As you can see, the dotted line creates this shape, and they're asking about the perimeter. So no problem. Because of the symmetry, all of these sides are the same. So if one of them is, say, d, we just calculate d and then we can multiply by 8. So the perimeter would basically just be 8d. So if I have the value for d, I can just multiply it by 8. Saves me a lot of time. So what I'll do is I'll just figure out the distance from 1, which is right here, to this, w plus times 1 plus I, that distance. So that will be my d, and that is 1 minus w, 1 plus I, and I've got to take the magnitude. Remember, these are complex numbers, so they behave a little bit differently than regular coordinate system. So expanding, this is going to be the magnitude of 1 minus w minus iw. And that, of course, is 1 minus w squared plus negative I squared w squared, all under the square root sign. And expanding this, I get 1 minus 2w plus w squared, so plus 2w squared, all under the square root sign. And I've got to make this substitution for w. Okay, so I've got to make that substitution of 1 minus 2 root 3 plus 1 over 2, and then plus 2 root 3 plus 1 over 2 all squared, and that's going to be under the square root sign. So this just becomes minus root 3 minus 1. And then this is going to be just the expansion. 3 plus 2 root 3 plus 1. And that's going to be over 4, but this 2 would make it a half, like that. And all under the square root sign. So this one cancels with that one. So I'm just left with minus root 3. This is 3 plus 1 is 4. 4 divided by 2 is 2. And then I've got a plus root 3. So all I'm left with at the end is just root 2, and that is my d. And if you recall, the perimeter is 8d, so the perimeter is 8 times root 2. So that is the answer, 8 root 2, and therefore number 24, the answer is B. For every m and k integers with k odd, denote by bracket mk the integer closest to m over k. For every odd integer k, let pk be the probability that n over k bracket plus 100 minus n over k bracket equals 100 over k bracket. For an integer n, randomly chosen from the interval n is between 1 and 99 factorial, what is the minimum possible value of pk over the odd integers k in the interval k between 1 to 99? Well, the first thing I'd like to notice, or help you notice, is that if you take the original equation that they give you, and instead of n, if you make a substitute of n minus k, it still remains valid, right? You can put that in there. So this becomes 100 minus n minus k, like this. And this side is, of course, unchanged as 100 over k. Now, what that helps us, hopefully, is understand that we can just consider p at k for values of n that are less than k, because it will always hold true. So if we just use this interval for n, it will make it a little bit more easier for us, and that's perfectly valid for this question. No need to go all the way up to 99 factorial, way too time consuming. So let's move forward with that. Now, another thing I wanted to point out is in this question, look at the answer choices, right? P at k is what we are interested in, right? The minimum possible value of p at k. Now, the probability of anything is always a fraction, where you have a numerator and you have a denominator. But the denominator is the total number of cases. Now, if n is between 1 and k, the range is from 1 to k, so the total number of cases is k. So the denominator is going to be k. So all we have to do is just look at values of k that match these denominators. And we actually only have to look at those 4 because k is odd. So we don't even need to look at 2 because 2 is even. So that, I think, definitely helps us out even more with regard to this question. So all we have to do is look at values of k, 13, 67, 87, and 99. Now we will start looking at this expression one at a time. This one right up here. We want, first and foremost, 100 over k to equal, let's say, 1. Let's start with that. That will only happen if k is greater than or equal to 67. Try it in a calculator, you'll see. And that means that we don't even need to look at 13, because 13 doesn't fall into that range. So we only need to concentrate now on those 3. So we narrowed it down even more. For this equation to hold true, if this is been set as 1, then one of these has to be 1 and the other one has to be 0. So in my first scenario, I will say that n over k is my 1. Right? If this has been set as 1, this has to be 1 and 0. Or this has to be 0 and that has to be 1. So my first scenario is that I'm letting this n over k equal to 1. Now, the only way that's going to be equal to 1 is if you have the following parameters for n. N has got to be greater than k over 2, or has to be less than k. If it's in that range, then that will be 1. And then if this is 1, then this has to be 0 in order for it to match up. So we have to set 100 minus n over k equal to 0. And that will only happen for certain values of n. And we'll discuss that in a moment. Now let's look at the other scenario, which is when this is 0 and that is 1. So now n over k is 0 and this is 1. So that means in my second scenario, I'm setting n over k equal to 0. And that is true when n is less than k over 2, right? If n is less than half of k, n over k will be less than a half, and the closest integer to that is 0. Now we have to set this equal to 1. So that means 100 minus n over k, that is going to be equal to 1. So these are our two scenarios, and let's talk about these. First, let's talk about this one because it's a little bit easier. If 100 minus n over k is equal to 1, that is true when 100 minus n is greater than k over 2. But 100 is greater than k over 2 plus n. Because if you remember, this was my original range for n. And if that is my range for n, and you first look at this, the first thing, of course, you just put, let's say, the n on the other side. So you have k over 2 plus n, right? Now, n, according to this, is less than k. So if you continue this inequality, considering the fact that k is less than 99, then you can substitute k here. It's always going to be less than 100, right? Because it's less than or equal to 99. And then that is always going to be greater than k over 2. And it's also going to be greater than k over 2 plus n. And the reason this holds true is because of this condition that we had set earlier. And this is always true. So because it's always true, pk in this case is 1. Probability is 100. So 100%. So not much help there. So obviously the answer to our question is going to come from this part of the question. So now let's concentrate on that. We have a scenario that n is between k and k over 2, and we want this to equal 0. So that means we want 100 minus n to be less than k over 2. If it's less than k over 2, this will hold true. So rearranging this, that means 100 is less than k over 2 plus n. And let's take into consideration this inequality. So that means 100, which is less than k over 2 plus n, is also less than k over 2 plus k, right? Because n is less than k. And this, of course, is 3k over 2. Now what we have to do is remember our only remaining values of k were 67, 87, and 99. For each of these, let's figure out what we get. And we are using the inequality 100 is less minus this one right here. 100 minus k over 2, I'm just putting n in the middle, is less than 3k over 2. All right, so let's figure this out for k equals 67, 87, and 99. If k equals 67, we have the following numbers. 66.5 is less than n and less than 67. Because remember, n is less than k. Right here, our original parameter. n is less than k. So that I can't really go up to 3k plus 2. I can only really go up to k. So I can only write k there. So that's why when k is 67, we have these numbers. When k is 87, we will have 56.5 is less than n is less than 87. And then when k is 99, we will have n is less than 99 is greater than 50.5. And as you can clearly see, the range is smallest when k is 67, the range for n. So clearly the minimum pk is when k is 67. And if you're interested, the actual formula for calculating pk is 1 over 2 plus 1 over 2k. Interestingly, you don't even need to figure out what pk is. All you have to do is figure out which of those values of k in the denominator give the smallest range for n. But if you want, you can figure this out. And this is going to be 1/2 plus 1 over 2 times 67. And if you do the math, you will get 34 over 67. But like I said, that 34 over 67 value is not even required. All you need to know to figure out this question is that k is 67 and that one of those denominators is 67. So regardless, we got the answer, and therefore number 25, the answer is D.